Right, so what types of functions are continuous and where? So a few nice and easy ones are constant functions like f of x equals c, a constant. Those are continuous at every real number. A constant function just looks like that, right? And so no matter what real number you pick, yeah, it's continuous there. Another really basic one would be f of x equals x. Yes, that function is continuous everywhere. Let's take those two facts for granted, okay? That those are continuous at every point, at every real number. So then there's a theorem from the textbook. It's Theorem 211. If you have two functions f and g, which are continuous at some number x equals c, then the following functions will also be continuous at x equals c. First, constant multiples, b times f of x for any constant b. So that means that if we know that x is a continuous function, then like, for example, 4x is continuous at every real number as well. Okay, that's for any constant multiple I could pick there. Second, sums and differences. So if you take two functions that you know are already continuous at c and add them together, that will be continuous. So I could like add another function, like a constant function, let's say add 12. Now that function is continuous at every real number, and I know that from this theorem. Products, if you take two functions which are continuous and multiply them together, that result will be continuous as well. So in particular, I could take x times x and make x squared, right? X is continuous, let's multiply it by itself. It's also continuous, so I can get x squared. And by that, similarly, I can get x cubed, x to the fourth, etc. Okay? And all of those would be continuous functions. I could then take constant multiples of those and then add them together. And what are we approaching? Suddenly, if we're taking constant multiples of powers of x and adding them together, we're going to get 3x cubed plus 2x squared minus 14x plus 2.5. Let's throw in a non-integer there. What kind of functions are we dealing with here? We're building polynomials. Okay, so this theorem is telling us that starting from some very basic facts that constant functions and y equals x itself are continuous everywhere, we've actually been able to conclude here with the theorem that polynomials are continuous at all real numbers. And then the fourth part of this theorem is that quotients are continuous. If you make a fraction with a function divided by another function, that's going to be continuous as well, as long as f and g were. And as long as f of c, the c being the point in question you're asking about, is f of c is, g of c is not 0. I jumbled that there. As long as your denominator is not 0 is what it comes down to. Right? As long as you're not dividing by 0, then it's still continuous. So that means that if you take something like a rational function, let me do this, a rational function, where you're taking a polynomial divided by another polynomial, let's say like x cubed minus 2x plus 1 over maybe x squared minus 4, something like that. That's going to be guaranteed to be continuous at every point at which the denominator is not 0. So in this case, that's continuous for all x not equal to 2 or negative 2. Which would be the two roots of the denominator polynomial. Okay, those would be values where something else might be going on. In fact, what's going on usually is a discontinuity, usually an infinite discontinuity at those roots, unless one of those roots happens to also be a root of the numerator, in which you might end up with like a hole. You may remember talking about learning about vertical asymptotes versus holes in college algebra. That hole would give you a discontinuity as well, except it would be removable instead of infinite. So so that's what we've got here. It's our first theorem about continuity. We're going to look at some other ones as well.